Hello students, happy morning. Class 12 Physics, Unit 6 Ray Optics continuation video. In our previous classes, we discussed the phenomena of light in ray optics, that are reflection, then refraction, then dispersion. Here one more phenomenon is there, that is scattering of light. Scattering of light. Scattering, that means if a light fall on a particle having the size A, the path of the light is deviated. That is known as scattering of light. Okay, here let me see the scattering of sunlight. Scattering of sunlight. We know the light from the sun have to travel a particular distance and reaches the earth. Okay, in between the sun and the earth there will be a earth atmosphere. Okay, in that atmosphere there will be a large number of water droplets are there and some dust particles are there. Here this is the actual path of the light from the sun. Okay, here this particle present in the atmosphere that deviates the actual path of the light, that is known as scattering of sunlight. Okay, here due to this phenomenon, the sky appear as blue in daytime. Okay, in daytime sky looks blue in color. And during the sunrise and sunset, the sky appear as reddish orange. Okay, and we know very well some clouds are white and dark. Some clouds are dark. Okay, that also due to the reason of scattering of sunlight. Okay, this scattering take place in two cases. In first case, the particle present in the atmosphere having the size A, that is less than comparing with the wavelength of the light instant on it. Okay, here this type of scattering is known as Rayleigh scattering. Okay, this type of scattering is known as Rayleigh scattering, because here the particle present in the atmosphere having the size A, that is less than comparing with the wavelength that instant on the particle, then there will be a scattering take place. That means deviation of light rays. This scattering is known as Rayleigh scattering. Okay, during this scattering, the intensity of the light scattered, that is inversely proportional to fourth power of the wavelength. Okay, intensity of scattered light, that is I, is inversely proportional to fourth power of the wavelength. That means if wavelength increases, amount of scattering decreases. If wavelength decreases, then the amount of scattering increases. Okay, by using this law. Okay, this is a Rayleigh scattering law. Rayleigh scattering law. By using this law, we can show the reason why in the daytime the sky look blue in color, and during the sunrise and sunset the sky appear reddish orange. Okay, we know during the daytime the sky looks blue. We know the Rayleigh scattering law, the intensity of the scattering is inversely proportional to fourth power of the wavelength. Then the colors in the sunlight, that is indicated as WebGR. Okay, here it is a order that indicate the increasing order of the wavelength. Okay, violet is the shortest wavelength comparing with the red. Okay, red have the longest wavelength. Here violet is the shortest wavelength, so it is scattered more. Okay, see, it is intensity of scattering is inversely proportional to fourth power of the wavelength. If wavelength is less, amount of scattering is more. But our eyes are only sensible to blue. The next color to violet is blue, so blue color will be scattered more comparing with the red. Okay, see, this is our earth. Here this is a sun. Our earth rotate in anti-clockwise direction. Okay, here the ray of light from the sun in a straight line. Okay, here this is the atmosphere. Okay, we know at the noon time we are very close to the sun. Okay, here there is observer. He looks the sky. At that time, see, the blue as the shortest wavelength, so it is scattered more. It is a blue. But the red, that is the longest wavelength, that is least scattered. Here this is red. Okay, so the observer looks the sky, it will look as a blue in color. Okay, then our next case, that is during sunrise and sunset. During sunset and sunrise, the sky look as reddish orange. Okay, this also from the Rayleigh scattering law. Intensity of the scattering is fourth power of the wavelength. Okay, at the time of sunset and sunrise, the light from the sun, okay, the light from the sun have to travel larger part of the atmosphere. Okay, at that time we know we are far away from the sun. Here it is observer. He is observing the he is observing the sun. At that time, here it is atmosphere. Here we know the blue, that is less wavelength, that will be scattered more. But the red, that is greater wavelength, that is least scattered. That's why at the time of sunset and sunrise, the person looking the sky around the sun, that look as a reddish orange. Okay, here these are the cases only the size of the particle present in the atmosphere, that is less than the wavelength of the light instant on that particle. Okay, in next case, that is the particle size is greater than the wavelength instant on the particle. Okay, here also scattering take place, that is known as non-Rayleigh scattering. Non-Rayleigh scattering. Here this non-Rayleigh scattering, that does not depends on wavelength. Okay, here there is no rule that has I is proportional to 1 by lambda power 4. Okay, here there is no rules. Here in this non-Rayleigh scattering, it is independent of the wavelength. Okay, so the intensity of the scattering is equal for all the color, independent of wavelength. Then the intensity of the scattering. Scattering is equal for all the color. Okay, here this type of scattering that take place in clouds. Two more reasons are there. Okay, white clouds and dark cloud. Okay, here I consider a white clouds. Here I consider, first of all, I consider a cloud. That cloud consisting of a particle A, that is greater than the size of the wavelength. Okay, if suppose a light from the sun fall on a clouds, then all the colors that are scattered equally. Okay, due to this reason the cloud appear as white. This is the reason why the whitish appearance of cloud. But one more thing, we know the rain clouds that are dark in color, that are dark, that is because the condensation of water droplets on the dust particle. Okay, condensation of water on dust from water vapor. This makes the cloud opaque. It makes the cloud opaque, so there is no scattering take place in these clouds. That's why the cloud appear as dark. Okay, if suppose the earth has no atmosphere. Okay, if suppose the earth has no atmosphere, at every time the cloud, there is no cloud. Okay, if there is no atmosphere means there is no cloud. At every time the sky appear as dark. Okay, this is why the astronaut who that can see the sky above the atmosphere as dark. Okay, here in today's class we discuss the phenomenon of light, that is scattering of light. Scattering means deviation of the path of the light by a particle. Here we consider two cases. In first case, the size of the particle in the cloud. Okay, the size of the particle in the atmosphere having the size that is less than the wavelength of the light incident on it, that is, that scattering is known as Rayleigh scattering. From that we found that the intensity of the scattering is inversely proportional to fourth power of the wavelength. Okay, then the second case, that is the particle present in the atmosphere having the size greater than the wavelength. Okay, for that case, that is known as non-Rayleigh scattering. Okay, then let me see a short recap of this unit 6. Okay,